Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, we had did various numericals based on first of thermodynamics. Now we are going to do a different numerical based on that theory itself. So let us do it. So a question has been asked in which they are asking that a sample of a gas is present in a cylinder which is expanded from 2 liter to 12 liter at 1 atmospheric pressure. So during this process it absorbs 600 joules of heat from the surrounding, and because of that what will be the change in internal energy, that is what we have to calculate. So for according to the first of thermodynamics, since we know that the formula is delta U is equals to Q plus W. So here the heat is been provided and they are asking for the internal energy, but the work is not known to us. But we could simply calculate the work in this formula. How? We simply know that. But before that, let us extract the data from the given question and let us see what are the requirement and how can we evaluate those data so as to calculate the change in internal energy. So the given data is that is when a gas has been expanded, so the volume changes from 2 liter to 12 liter. This means the initial volume was 2 liter while the final volume was 12 liter, and the pressure that has been maintained in this process is P, which is 1 atmosphere. So the thing that we have to do, and from this data that we could find it out, as we could easily find it out what would be the work done in this process. So let us write the other data also that are being involved in this question, in which they are asking that during this process 600 joules of heat is being absorbed. A system if absorbs heat means the magnitude will be the same, but the sign will be always be positive because you are providing heat to a particular system. The heat will enter in the system and hence the heat will be positive. If the heat is removing or if it is expelling from a particular system, then the heat will be negative. So in this case the heat is being provided to the system by the surrounding. So the heat that is Q, which will be positive 600 joules, and that of they have asked that we have to calculate the change in internal energy, that is delta U. But before that we know that the formula of the delta U is nothing but delta U is equals to Q plus W. So the first thing that we have to calculate is what would be the value of W, so as we could find out what would be the value of delta U. So let us see the value of W is what. So W, that is the work, can be written as minus P delta V. So therefore in this case the pressure, that is 1 atmosphere, and the delta V is nothing but V2 minus V1. So in this case V2, which was found to be 12, minus V1, which was found to be 2. So in this case we have got an answer as 10 liter, and this is atmosphere because pressure unit is in atmosphere while this volume has a unit of liter. So therefore this is 10 liter minus 10 liter atmosphere, but we should write it in joules. So for that we have a formula, that is 1 liter atmosphere is nothing but 101.33 joules. So therefore for writing the value of liter atmosphere we have to convert it into joules. So the thing that we should do is we could write it directly as 10 multiplied by 101.33 joules, which is found to be 1013.3 joules, but in negative. So therefore this is the W that we have calculated. So by the help of this we could easily calculate what would be the internal energy. So let us see what is the internal energy. So the change in internal energy is, that is delta U is equals to Q plus W. In this the Q, that is the heat which was found to be 600, plus the work done during this process, that is it is minus, so minus of 1013.3 joules. So by calculating this thing we could get the answer as minus 413.3. So minus 413.3 joules of internal energy was being present in the system. So this is how we could calculate the internal energy, and this was a different kind of numerical in which work was also been involved, and we have calculated separately that what would be the value of the work. So this was a very much simple numerical. So I hope you will do this kind of numerical in your future, and let us see that what kind of answer and you will get. So share this video with your friends, and yes, don't forget to subscribe the Ekeeda channel. Thank you so much.